What if a heavily defended military base could be destroyed without a single warning? 4:41 a.m. 25 meters off Crimean shoreline. USV. 5.5 meters long. Matte gray. Conditions. Rough sea. 1.8 meters waves. Sealed electronics. Inertial navigation. Payload. 3 fiber-optic FPV drones. Hair-thin glass cables, 10 kilometers. No radio/satellite. 4 kilograms shaped charges. The strike. Operator cuts wireless. Point of no return. Russian sentries/radar miss it. 4:44 a.m. Inside perimeter. 4:46 a.m. USV stops. Launches drones. 140 kilometers per hour. Reaction. Russian AD fires. 1 drone intercepted. EW/jammers activated. Counter EW. Fiber optic drones unaffected by jamming. Drones split up. Impact. 1 drone hits a sensor node. Defense network blinded/guessing. 5:06 a.m. Surviving UAV. Skims low. 10 meters. Alarms. Tracers. Late. Target. UAV support facility. Blast doors open. Secondary explosions. Fuel/munitions. 1,200 degrees Celsius. Post-strike chaos. Fragmented updates. Russian patrol craft, 90 tons, responds. 5:21 a.m. USV exposed due to fiber lines. 1 UAV hits the patrol craft's bridge. Bridge disabled. Counterattack. Long-range strikes hit nothing. 5:22 a.m. Imbalance. Base functional on paper, but coordination stripped. Safety protocols overload systems. 5:24 a.m. Operational pause. USV disappears into maritime noise. Analysis. Damage measured in time/confidence/lost function. $120 million loss versus $300,000 cost. Conclusion. Modern warfare rewards system failure understanding over budget. No safe harbor. Maintain the line breaks for TTS. Ensure the tone is professional. Use British spelling/conventions, meters, kilometers, center, as N, UK, was mentioned in the original prompt's target. Make sure to keep the timestamps as clear anchors. Drafting segments. What if a heavily defended military base could be destroyed without a single warning? At 4:41 a.m., just 25 meters off the Crimean shoreline, a small unmanned surface vessel, USV, cuts through the water. Refining the fiber optic part. Ensure it emphasizes the immunity to jamming. Refining the cost part. $120 million versus $300,000. What if a heavily defended military base could be destroyed without a single warning? At 4:41 a.m., just 25 meters off the Crimean shoreline, a small unmanned surface vessel, USV, cuts through the water. It is barely 5.5 meters long, riding low, its hull painted matte gray to dissolve into the pre-dawn haze. There are no navigation lights, no radio transmissions, and no radar pings. The sea state is unforgiving. Waves rise to nearly 1.8 meters, slamming into the bow with enough force to drown exposed electronics. Inside the vessel, however, everything is sealed, stabilized, and calculated. The craft moves purely on inertial navigation, correcting its course hundreds of times per minute to counter drift, current, and swell. Hidden beneath its deck is the real payload. 3 fiber-optic FPV drones sit locked in place, each connected by hair-thin glass cables, stretching over 10 kilometers back to the operator. No radio, no satellite uplink, just light traveling through glass at near instant speed. Each drone carries a 4 kilogram shape charge, enough to disable armored systems far more expensive than itself. 10 minutes earlier, the operator sitting hundreds of kilometers away cut all wireless links. From that moment on, there was no abort button and no second chance. If the vessel is detected now, it will not run. It cannot. The mission has crossed the point of no return. On the Crimean coast, Russian sentries scan the horizon. Their radars sweep wide arcs calibrated for aircraft, missiles, and fast attack boats. They are not looking for a shadow riding inside the rhythm of the waves. At 4:44 a.m., the unmanned vessel reaches its final pre-launch waypoint. The attack is no longer approaching. It is already inside the perimeter. If you were responsible for defending this coastline, would you even know this threat was there until it was too late? At 4:46 a.m., the unmanned vessel halts at its programmed position. The deck opens. Within seconds, 3 FPV drones launch in rapid succession, climbing to 40 or 50 meters and accelerating past 140 kilometers per hour. Their movement is precise, rehearsed, and silent after the initial burst. This is no test. This is the strike. Russian coastal defenses react late but decisively. Radar screens light up with low-altitude contacts. A short-range air defense unit locks on and fires. A missile intercepts the lead drone at high speed, tearing it apart mid-air. One target destroyed. Electronic warfare follows immediately. Jammers activate across a 20-kilometer sector, flooding the airwaves with interference strong enough to sever satellite links and radio control systems. Under normal conditions, the remaining drones would drop out of the sky within seconds. However, these drones continue their run unaffected because their control signals are not in the air. They travel through fiber-optic cables, carrying clean, uninterrupted video back to the operators. 2 drones split wide, forcing defensive radars to track multiple directions at once. The third drops low, skimming just above ground level. As fire control systems struggle to retask, the low-flying drone reaches its objective and strikes a critical sensor node. The impact does not level the site, but it does something worse. By 4:56 a.m., the local defense network is no longer tracking targets. It is guessing. Missiles, guns, and jammers remain intact, but without reliable sensors, they are nearly useless. The defenders believe the worst is over. At 5:06 a.m., with coastal sensors blinded and command links fractured, the surviving UAV drops even lower, below 10 meters. It skims past cranes, radar towers, and stacked containers. Its speed surges to 165 kilometers per hour. Every second matters now. The defenders are recovering, the clock is closing. Inside the harbor, alarms overlap. Floodlights snap on. Tracer fire begins stitching the sky, unfocused and late. Rifle rounds chase a target that refuses to fly predictably. The UAV weaves, correcting its path dozens of times per second, guided by a live fiber-optic feed, immune to the electronic chaos saturating the air. The target is a reinforced UAV support facility at the pier's edge. The blast doors are still open, left that way during the sudden shift from routine readiness to panic. Inside, rows of unmanned aircraft sit partially fueled. Nearby, multiple warhead crates, each weighing over 180 kilograms, are staged for rapid deployment. Fuel drums stand closer than safety protocols ever allow. The UAV does not slow down. At 5:09 a.m., it drops to 5 meters above ground level and commits to its final vector. The camera feed stabilizes for a heartbeat, clear enough to reveal warning labels, serial numbers, and human silhouettes diving for cover. The shaped charge detonates on contact, punching through its initial target and injecting molten metal deep into the stored munitions. The first blast is sharp and contained. Less than half a second later, the secondary detonations erupt. Pressure waves stack. Fire races through confined spaces. Internal temperatures spike beyond 1,200 degrees Celsius. The facility's reinforced structure fails from the inside out. By 5:10 a.m., the base is no longer under attack. It has been structurally erased from the fight. At 5:20 a.m., the explosion inside the harbor forces an immediate shift in posture. Command channels flood with fragmented updates. Thermal alarms override sensor feeds. What should be a clear operational picture collapses into disconnected flashes of data. Within seconds, Russian commanders reach the same conclusion. This strike required a nearby launch platform, and it must be found before the situation worsens. The response is instant. A fast reaction patrol craft, displacing nearly 90 tons, breaks from its mooring and accelerates past 55 kilometers per hour. Its bow cuts through the water as deck-mounted searchlights sweep the surface. Heavy machine guns pivot, churning the sea into white foam in an attempt to flush out anything hiding below the waves. There is nothing to lock onto. The unmanned surface vessel cannot retreat. Its fiber-optic lines remain deployed, stretching kilometers back to the operator. Any sudden maneuver risks severing control. For a brief moment, it is exposed, slow, constrained, and vulnerable. A decision is made. One remaining UAV is redirected. The drone peels away and dives toward the patrol craft at over 140 kilometers per hour, descending steeply through sporadic tracer fire. The gunners track late. The target is too small, too fast, and too close. At 5:21 a.m., the UAV impacts the forward command section. The detonation is compact but precise. Shock pressure floods the enclosed bridge, disabling crew and systems simultaneously. Displays go dark, steering locks, the vessel swerves hard to port. Engines are still running, but are no longer controlled. The harbor entrance is left unguarded. In frustration, higher command authorizes escalation. Long-range strike assets are launched toward estimated launch coordinates, which are already several minutes out of date. The weapons arrive with overwhelming force and find nothing. The counterattack has expended millions in hardware, but control has not been restored. 5:22 a.m. What follows is not silence, but imbalance. Inside the harbor complex, systems remain powered and weapons remain mounted, yet nothing works the way it should. The strike has not erased the base from the map. It has done something far more destabilizing. It has stripped the facility of coordination. Emergency protocols trigger automatically. Fire suppression systems flood multiple sectors at once, forcing crews to evacuate areas that were never meant to be isolated simultaneously. Power reroutes overload secondary circuits. Internal communications lag by 20 to 30 seconds, an eternity during a crisis. Commands are issued, then contradicted, then cancelled. The destroyed UAV facility was not just storage. It was a hub. Before the strike, the base supported dozens of unmanned sorties per day, with launch cycles measured in minutes. Now, those operations stop entirely. Fuel access is restricted, warhead handling is suspended, maintenance crews are locked out by safety interlocks that cannot be reset without full diagnostics. On the water, the situation is no better. The disabled patrol craft drifts near the harbor entrance, its presence forcing traffic to halt. Smaller vessels hold position, unsure whether the threat has passed or simply moved. Radar coverage exists on paper, but without synchronized sensors, tracking data arrives incomplete and inconsistent. Every defensive layer is still physically there, but none of them trust each other. By 5:24 a.m., Command makes the only viable call. Operational pause. All outgoing movements are frozen. Incoming assets are rerouted. The base shifts from defense to damage assessment, from readiness to containment. The unmanned surface vessel is no longer in the area. It has gone cold, blending back into civilian maritime noise. Its mission is complete. The cost of the strike is not measured only in destroyed equipment. It is measured in time lost, confidence shaken, and a fortress that still stands but no longer functions as one. 5:26 a.m. By the time the smoke begins to thin over the harbor, the real damage is only becoming visible. On paper, the base still exists. Runways remain intact. Defensive vehicles are parked where doctrine says they should be. More than 70% of physical infrastructure is technically undamaged. Yet, the command picture tells a different story. In less than 20 minutes, a facility designed to project control across hundreds of kilometers has lost the ability to protect itself. The immediate assessment is grim. UAV operations are suspended indefinitely. Fuel reserves cannot be accessed without risking secondary incidents. Ammunition handling is frozen, pending structural inspections that will take days, not hours. What was once a forward operating hub capable of sustaining round-the-clock unmanned patrols is now limited to passive observation. The psychological impact spreads faster than the damage itself. Crews rotate through checkpoints with visible hesitation. Radar operators question every return. Officers authorize manual overrides that contradict automated systems, then reverse those decisions minutes later. The defensive doctrine has been broken. Not by overwhelming force, but by uncertainty. Beyond the harbor, the consequences ripple outward. Naval movements along the coast slow dramatically. Ships increase standoff distance, stretching supply routes and response times. Patrol patterns are rewritten overnight, expanding coverage zones by 30 to 40%, yet offering less confidence than before. The fleet is still afloat, but it is no longer comfortable near the shore, and then the cost becomes unavoidable. Preliminary estimates place the material impact of the strike at over $120 million. This is not just from what was destroyed outright, but from what can no longer be used. In contrast, the attacking system, a single USV and a small cluster of UAVs, represents a fraction of that figure. The total cost is likely under $300,000. This imbalance is impossible to ignore. This was not an attack designed to capture territory. It was designed to erase assumptions and demonstrate that layered defenses mean little if they can be bypassed by systems that do not play by the same rules. By 5:28 a.m., command doctrine begins to shift. Emergency reviews are ordered. Defensive postures are rewritten. Questions are raised that cannot be answered quickly. If this harbor is vulnerable, what else is? The strike ends without a pursuit, without a follow-up volley, and without a visible enemy to point at. What remains is a strategic void, and the realization that in modern warfare, safety is no longer a place. It is a condition that can disappear in minutes. By the time the sun fully rises over the Black Sea, the battlefield looks deceptively calm. The smoke thins, the alarms fade. Crews return to their stations. On the surface, it appears that the base survived. Walls stand, vehicles are parked, and flags fly. But something fundamental has changed. What was exposed here is not just a vulnerability in hardware. It is a fracture in belief. The belief that layered defenses guarantee safety. The belief that cost equals dominance. The belief that control can be bought and permanently maintained. This strike did not rely on overwhelming force. It relied on timing, asymmetry, and precision. A system costing hundreds of thousands neutralized infrastructure worth well over 100 million. It did this not by smashing everything in sight, but by targeting the logic that held it together. Sensors before shooters, coordination before chaos, and confidence before collapse. That is the lesson that lingers long after the damage is assessed. Modern warfare no longer rewards the side with the loudest weapons or the biggest budgets. It rewards the side that understands how systems fail and how humans react under pressure. It rewards those who see how technology depends on assumptions and how a single blind spot can undo an entire doctrine. For the defenders, this was not just a loss of equipment. It was the realization that there is no longer a guaranteed safe harbor. Not on land, not at sea, and not behind layers of steel and code. So now, the question turns to you. If small, adaptive systems can bypass defenses built for another era, what does the future battlefield really look like? Are fleets and fortresses evolving fast enough? Or are they becoming expensive targets waiting to be tested? Let me know what you think in the comments. If this kind of analysis matters to you, consider subscribing and share this story with someone who still believes modern wars are decided by size alone. Because the next strike won't look the same.